Alright, so in this video, we'll be looking at a limiting reactant problem. So, we're given that a 15-gram sample of butane is combusted in 60 grams of oxygen gas, and the reaction is given below, and we have to find the limiting reactant, to calculate the mass of water that's produced, and determine how much of the excess reactant remains unreacted. So this is a very standard limiting reactant problem, and so you should be very comfortable in knowing how to solve these types of problems, as they're very likely to come up on any exam you may take, whether you're in AP Chemistry or general chemistry at university. But yeah, so how do we start off with a problem like this? Well, we start by converting both the reactants to moles. And we're given that we have 15 grams of butane and 60 grams of oxygen. So how do we convert from grams to moles? Well, we need that molar mass. So first, we'll start by calculating the molar mass of butane. Right? How do we go about doing this? Just as we would with any other molar mass calculation. So we just look at how many of each element make up the compound and account for exactly how many of each element are in that compound, right? It's C4H10. So we would just simply doing 4 times the molar mass of carbon, which we can find in the periodic table, plus 10 times the molar mass of of hydrogen, which again is available in the periodic table. Working out this calculation gives us an answer of 58.12 grams per mole. So this here is our molar mass of butane. So given that we're reacting 15 grams of butane, and we have our molar mass to be 58.12 grams per 1 mole of butane, we can simply cancel out, our grams, giving us an answer in moles, in units of moles of butane. Here, that's going to come out to 0.258 moles. So now let's just keep track of this number, or keep this number in mind. I'm just going to clear it out of the way to make some room for the next calculation. So now we just have to do the same exact thing, but for our oxygen. However, again, oxygen is an element, so we don't have to worry about calculating that molar mass. It'll be available to us in the periodic table. Though, again, this is molecular oxygen. That's an important thing to keep in mind. This is O2 that we're dealing with. And so, well, in our periodic table, we are given the molar mass of oxygen alone. Oxygen's molar mass is about 16 grams per mole. Though here we're looking at the diatomic oxygen, right, O2, which means that when we're converting this 60 grams of oxygen, diatomic, right, we should be dealing with this number times 2. So we would just be doing 32 grams of oxygen per 1 mole of oxygen. Again, canceling out our units, grams of oxygen, gives us our answer in units of moles of oxygen, in this case 1.875 moles of O2. Alright, so now that we've got both, again, let's keep this number in mind, but now that we've got both of our reactants converted from grams to moles, we can move on to the next step, which is determining that limiting reactant. So how do we do this? Now we just have to use the mole ratio from the balanced equation. What does that mean? Well, we see that for every 2 moles of butane, we react 13 moles of oxygen. So just writing this out in sort of a ratio format, for every 2 C4H10, that is butane, we have 13 O2. So that's that mole ratio. So now that we have this, we have to figure out how much oxygen we need for the amount of butane that we have. So, just from our calculation earlier, we found that we have 0.258 moles of butane, that is C4H10. So, according to this mole ratio that we acquired, again looking at our balanced chemical equation, how much oxygen do we need? Well, we see that for every 2 moles of butane, we need 13 moles of oxygen. So, well, canceling out our units of moles will give us how many moles of oxygen exactly that we need to conduct this reaction. And that would be 1.677 moles of O2 is required. And well, looking at our calculation from before, we noticed that we have 1.875 moles of oxygen, and we only need 1.677 moles of oxygen. So we have enough. And that means that this butane is actually going to be our limiting reactant. So I hope that makes sense. Just to reiterate, we calculated the number of moles of each of our reactants. Now, using this mole ratio that we can get from our balanced chemical equation, we figure out exactly how much oxygen we needed given the amount of moles of butane we have in order to complete this reaction. And we find that we need this number, 1.677. And this 60 grams of oxygen is actually 1.875 moles. And that means that we have more oxygen than we actually need in order to completely react this 15-gram sample of butane, which means that we have an excess of oxygen gas, meaning that butane is the limiting reactant. All right, so we have identified the limiting reactant. Part A has been completed. Well, now what do? We can move on to part B, calculating the mass of water produced. How do we do that? Well, again, we have to go back to our handy balanced chemical equation, right? So looking at that balanced chemical equation, we can see that for every 2 moles of butane, we're able to yield, again reacting with our 13 moles of oxygen, but we're able to yield 10 moles of H2O. And so that means, given that we have 0.258 moles of butane, according to this balanced equation, we can say that, again, every 2 moles of butane yields 10 moles of water, giving us our answer of 1.29 moles of H2O. All right, so now, since we're asked for the mass of water produced, we cannot leave our answer in moles here. If you did leave your answer in moles, that would be an incomplete answer. And that is not what we're trying to do, obviously. So what we would do now is convert this 1.29 moles of H2O into grams. So trust me when I tell you, again, that the molar mass of water is 18.02 grams. Oops, excuse me, that is wrong. We should be writing that on top. So for every 1 mole of water that we have 18.02 grams of water per mole, right? Again, this is very simply calculated like we did previously. You just add up the individual molar masses of the elements that make up the compound. But doing so gives us an answer of 23.25 grams of H2O. This here is our answer to part B. And now for the very last part, finding the amount of excess reactant that remains unreacted. Well, thinking back, what is our excess reactant? We know that butane was the limiting reactant, and excess reactant in this reaction here is oxygen. We already calculated earlier how many moles we have and how many moles we need. If you can remember back that far, we have calculated that this 60 grams of oxygen is actually 1.875 moles of oxygen. And we calculated that in order to fully react this 15 grams of oxygen, we only will be using 1.677 moles. of oxygen. And so, doing this little quick arithmetic, we see that 0.198 moles of oxygen will be remaining unreacted. And so this is that excess reactant that remains unreacted. And again, we can leave this in moles, but more traditionally, we would have to convert this into grams, right? We want the mass that is unreacted because we're given in masses. We're dealing with masses in the problem statement, so it's more, common practice to also give our answers in those units. So that shouldn't be too hard. We just have to convert this one number from moles to grams. We already got our 32 grams. Oops, I keep doing this today. All right, that's 1 mole is 32 grams of oxygen. And that gives us an answer of 6.34 grams of oxygen is going to be unreacted. And that here is our answer to part C. All right, that wasn't too hard, was it? This was a rather straightforward limiting reactant problem. Very common type of problem that you will 100% come across in class and surely on an exam or a quiz. So it's important, again, that you're very comfortable with identifying what your limiting reactant is, calculating the masses of the reactants and products, depending on what they're asking for, and also seeing how much excess reactant remains unreacted. Well, that brings us to the end of the video. Again, thank you so much for watching. I hope if you liked the video and it was helpful, you can leave a like, subscribe, and comment any future topics that you would like videos made on. I'll see you guys in the next one.